Very good morning, friends. Myself, Dr. M.H. Chennaiya, and in today's video, we are going to work out a problem on the development of a hexagonal pyramid which has got a base of 30 millimeter and height is equal to 60 millimeter, and this is being cut by two section planes, both being normal to VP, and one of them is horizontal and the other is inclined at an angle of 40 degrees to the horizontal, and both of them intersect at the mid height of the axis. When I say mid height, so I should take a height of 30 millimeter from the base and mark that point. And we are required to draw the development of the lower part of these two section planes. Friends, here I have constructed a regular hexagon of side is equal to 30 millimeter. At one of the edges of that, say this edge is parallel to VP, and this is the front view, and we represent this by O dash, and if you call this point as A, B, C, etc., this is A, B, point C, D, E, and this is F. A, B, C, D, E, F. These are the six corners of the base, and I will mark here O, comma O1. O is the vertex of the pyramid, O1 is the center of the base, and the axis of the solid front is now perpendicular to HP. So that's very obvious. Whenever any pyramid is resting on HP, its axis will be perpendicular to HP. Friends, I have marked all this. Let me transfer all these points to the front view, like A dash, and this is B comma F, B dash comma F dash, B dash, F dash, and this is C comma E, C dash, E dash, this is D dash. So this is the front and top views. Now we have to mark the section plane, and he has given one of the section plane is horizontal. So from the midpoint I am going to write a line here representing the horizontal section plane, and the other section plane is at an angle to that, at an angle of 40 degrees to this, and I will show here 40 degrees. And the first section plane I will call it as 1 comma 1, and second is 2 2, and they are intersecting at the midpoint of the axis. So 2 2 is the second section plane, 1 1 is the horizontal section plane. Friends, very obviously, after this is being cut by two section planes, we have to just mark the portion that is to be retained for the purpose of development. So this is the portion of the solid that will remain for the purpose of development. So this is how I am going to show them. So we will call this part as P, for which you are going to draw the development for the lateral surface of that. Now friends, you can see here this O dash D dash is one of the slant edges whose top view is OD. Since OD is parallel to VP, this O dash D dash will give you the true length, and similarly O dash A dash will also give you true length because OA is also parallel to VP. Now friends, here you can see both the section planes are seen as lines in the front view, and this is the portion for which you need to draw the development for the lateral surface. Now first of all, let us assume that this pyramid is not cut by any section plane, and let us draw the development of that, in which you will have six triangular faces on its lateral surface. So friends, you know very well that all the developments are drawn to true size or actual size. So here O dash A dash is the true length. I am going to draw a line here of length is equal to that. Say this is O, and taking this O dash A dash as length or the radius, I am going to draw an arc through this. Okay. So say this is the arc that is drawn with the true length as the radius. and the center as O. Here friends, for the base, there are 6 edges of the base, each having measurement of 30. So I am going to step up 6 such lines, 30 millimeter, 30, 30, 30, 1, 2, 3, 4, 5, again another 30. Say this is the last line, and the last line is to be joined to this O by a thin line. Friends, this is how the development is going to be there. And now friends, the base of the pyramid has got straight edges, and all these, whatever the lines you have got, you have to show them by visible lines or dark lines, full line. You can retain this construction part. This is the next, second, and finally this is the edge over. And all these base corners or the base edges are to be joined to O, the vertex. So let me show them by very thin line. This is one, second, third, fourth, 5, and this is going to be the 6th. So I will divide that into 6 equal, and each of these dimension is equal to 30. Friends, listen carefully, be patient, and you will not have any difficulty in understanding this development of this. Now friends, let us see from where we should draw the development. Here you can say both the horizontal and inclined section planes are cutting the solid, but none of these slant edges from O to O dash A dash to O dash F dash are removed after the object is being cut, and hence we can start the development from any point of your choice. Let me say I am starting from A. So this is slant edge OA, OB, OC, this is OD, OE, OF, and again OA, because the first and the last point should have the same numbering. So this is how it will happen. Now let us consider the section plane 1, 1. As you are seeing, the section plane is cutting O dash A dash, this slanted at this point. You know O dash A dash is a true length. Take this distance from O dash to that point and mark on that OA. So it is going to be somewhere here. This is on OA, again on OA we have got here. These are the 2 points we got for this. Similarly, OB and OC, that is OB and OF are cut here, but again they are not the true length, and hence this point is to be transferred to the true length generator, and again obtain the same measurement on OB and OH. So this is on OB, and again this is on ABC, OF, sorry, DE, yeah, OB and OF will have the same measurement. So friends, on the same line, let's see, it is cutting, you forget about it, it is cutting this slant, what you call the inclined section plane, is cutting OC and OE at this point. But this O dash C dash 1, O dash F dash are not the true length, OC and OE, sorry, this is OC and OE, C and E, right? So A is 1, 2, 3, 4, 5, 6. A, B, C, D, E is F, correct. So OB and OF are cut here. OA we have marked, OB we have marked, OF we have marked, and we have got here OC and OE cut here at a height higher than this. So this is not the true length. Transfer that to the end generator or the end slant edge. Obtain that measurement on only OC and OE. So this is OC and this is OE. OC and OE will have the same height. Finally friends, here the section plane 2 is cutting the true length generator O dash D dash at this point. This is true length. Take that measurement on the slant edge OD. This is OD. Friends, now there is an important, and this particular problem on this hexagonal pyramid is a beautiful problem. And for your kind information, I would like to mention here this problem I had worked out when I was a student of first year B in the year 1970. That is, after 52 years, I am working out this problem, and this is very interesting. What is the interesting part of this? I will show you. See, here the section plane 1 and section plane 2 are meeting here. So this point is exactly between FE and BC. So you have to mark one more point between BC and FE. So friends, BC you have got here. You write a thin line through that. And similarly FE, another line through this. And this point, whatever you have got here, is exactly and the same height as that of OA, OB, etc. So I have to mark this at the same height as this. Similarly, here also we have at the same height. So friends, I have marked two more points there. Okay, so join all these points so obtained by continuous straight line. So I am going to mark this edge, then this edge, we have this, again this edge, this edge. Remember friends, here this edge, shorter portion is parallel to this edge is parallel to this, and here this is parallel to AB, and this portion is parallel to that, because this horizontal section plane from here to the midpoint of BC will have the length parallel to the base. So this is parallel to base, this is parallel to this edge, and so on. Friends, after this, we will just join all these points to the base. So this is one such OA. We got again OA here. Then OB we have to show, and here we need not show anything. Again, this has to be shown by a visible line. This OD by a visible line, and OE visible line. Similar to this need not be shown, and this one. And the complete base of the solid, that is AB, BC, CD, DE, EA, and EF, and FA, they are all to be retained. And this portion from here to this point. And if you want to mark the points, you can mark like this: OA1, OB2, this point is 3, this is 4, uppermost point is 5, this is 6, this is 7.8, and this point is 1. So on 6 base edges you have got 6 points plus 2 for this midpoint. So there are totally 8 points. So I will show only some 1 or 2 important points, because there is no space to accommodate all these 8 points in the front view. So I will show one on this. And the point of intersection, where common point is 3, 7. This is 3, 7 at this point. 3, 7. And the last point on that is 5. So only I have shown 3, 4 points. This is the point 5. Friends, if you call this as point P or the portion P, this figure will give you the development of part P. And remember, all these base edges should be dark lines, because the section plane is not touching the base. So this will give you development of P, the lateral surface of the lower part of the hexagonal pyramid, which is being cut by two section planes. One is horizontal and the other inclined at 40 degrees to the horizontal, both intersecting at the midpoint of the axis. Friends, please go through the complete video without skipping any portion of it in between. And if you like this video, please share this video, and also the channel link of my YouTube videos, that is Engineering Drawing by Dr. M. H. Annaya, with all your friends. And have a wonderful day.